All right, so now we're down to the last portion of this build, and we have the Tweed Preamp, and that's going to be helping out this particular section here, which is the bass channel, as along with the deep switch. And then we have what they call remaining signal caps in this kit. So if we look at what's in here, and I bring out the schematic for that. So here's the AB165 to the AA864 plus Tweed Preamp for the bass channel. Now, somebody, I think Mike has made a little highlight here, combined instructions for use of blue molded caps. Now, I don't have the blue molded caps, so I'm not going to be able to do the exact modification here. They mentioned take the 2.02 blue molded caps from the original 165 output stage and use them in the Tweed Preamp. Well, that would have been the two caps that were here, and they would like you to move them over to here. We're not going to be able to do that. So is they have the kit here, Tweed Preamp, and what they have supplied us with will do the same thing, if not better, in my opinion, because these Jupiter caps are quite amazing. And if I can not break my cap here. So the value, as we can see, this is a 0.1 microfarad, and they want us to change these two out to 0.22s. So we're going to end up making this circuit here. Two 100K resistors, a 330 picofarad disc cap, which is here, 2.022s, and one UF. So they have supplied us with that wonderfully. So here's the one UF that will go here, and then here are the 2.02 UF that will go here and here. Now, they have supplied us with another 330 disc cap. I don't suspect this one is going to be bad. I'm going to leave that in. If I need to change it in the future, I've got this one. Great. So these guys will go here, and that will get us into the Tweed Preamp for the bass channel. Within this section that we're going to do, I'm also going to replace these 0.01 capacitors. And that's going to be out of this kit that says remaining signal caps. We should have a 0.01. That's going to be for this guy here. There it is. And then there is a 0.05. That's going to replace this 47 here. So those two guys will be in there. And then we've got a 0.01, and that's for the replacement of here. So if we look at what they sent, they made a highlighted schematic for us. This isn't my work, and they did a real nice job here to highlight. In green, they highlighted the electrolytics that we needed to replace. That's these guys that have already been replaced, and then the three chocolate drop here caps that we're going to be replacing. They also highlighted these 7 individual resistors, and they've supplied those for us if we need them. And these are the AB165 plate resistors. As you can see, all of these resistors that are in here are these guys that are down, just populated through here, right? Especially these 700K resistors. They're known to create noise. They make mention of that in the kit. And if we need to, we've got them. They provided them for us. Wonderful. So additionally, they provided us with the 68Ks that are typically here in this section in case we have bad resistors. So they've really outfitted this kit extremely well. You can see that's these two resistors here, these two resistors here. Typically these don't go bad unless they've got some physical damage. Somebody's bumped them or something to that effect. But they are kind of hanging in the wind, so they are susceptible a little bit more to vibration at any rate. But they've included those as well if we need to replace them. So I think I'm going to do a negative feedback circuit on-off switch, which utilizes this old grounding switch that we disconnected from the input power source. And a lot of guys do this. I think that it's a necessary thing. Why let the switch go to waste, right? All right, so on the AA864 schematic, you can see that there's an 820 there. So we've made that change in this cap right here. Regardless, so that's a good thing. So the negative feedback loop, you can see that it goes to the external speaker jack on both schematics. So here's that wire if we follow it down, and it goes right to the external speaker jack. So what is common is to take this wire, run it over to one side of the switch, and then run a wire back to that same position. So that's what I'll do now. So now we're at the section where he talks about, goes through a lot of precautions, and there's a few different ways to set bias, of course. And I've used this method in the past, works well for me. And we'll do another test in a little bit, but we'll start with this to see where we're at. So for 606 tubes, adjust the bias pot to get a reading across 1 ohm resistor somewhere in the 30 to 35 millivolt range, and different for 6V6. When I added the 1 ohm resistor, I added it from pin 8 to ground on both sides. So I'm in the millivolt settings. I'm going to put my black lead on the right. Doesn't really matter, but you'll get a negative voltage if you have it different. So let's go here. See, that's positive 17, 18, somewhere in there. If I reverse them, goes negative. So don't worry about that. That's regardless, right? So we got positive 17.5 or so on the left side. Let's look at the right side here. 19. All right, so let's go for this now. So if I go to the left, it was all the way to the left. So I'm going to bring this up now. And the recommendation, if we look here, was between 30 and 35 millivolts. So I'm going to run it on the lower side at about 32. So let's split it in half, 32.5 if we can get it to settle. All right, so this is the second way that you can do a bias. And again, there's more than one way. This is just like several of the other do-it-yourself made easy, where you put the device in between the power tubes. And in this case, I can select 2 power tubes or 2 9-pin sockets, whatever I'm after. So turn it on here. We can see that this tube here to the left is at 422 somewhere in there volts, and the one to the right, which is here, is pretty much spot on. So a really good match set of tubes. And now we can check the millivolts here. So we've got 31.9 on this side and 30 on that side. Well, a little bit less. So if I move this pot here, we can see that there's going to be a change. Okay, it's going down to 29, 28. You can check the one on the right. She's up to 30. You can go the other direction. That's at 32. Now she's at 30. Check the one on the right, 32. It's at 33. One on the left is now 31. So I'm going to leave this on the lower side. I think I like the 33 range the most, 32 to 33. So we'll go somewhere in there. I'm not that picky. 31. Yeah, run them a little bit colder. I like a clean amp, so that's why I got this particular amp. So at any rate, that's another way. So if you remember, we put an 82K here and 100K here for what they call the long tail pair for the AT7. So that's going to actually give us a little bit different readout here, and that's the desirable effect, right? So they're slightly off each other and they give a more cohesive sound wave at the end, which is the idea. Well, there seems to be some sort of tradition somebody started to put out all the the parts you replaced in repair. So at any rate, that's a whole lot of parts for this amp. All right, let's take a quick moment and review what's been done to this amp. The 3-prong power cord has been replaced. The 2-prong power outlet socket has been bypassed. The ground switch has been repurposed as a negative feedback in and out loop. The transformer itself has been cleaned up for the evidence of overheating that I believe was caused by this terminal tie strip grounding against this lug. I added some shrink wrap in there for future in case it were to happen again. I did end up replacing the 100 UF here to a 47. Of course, we know that that resistor has been replaced. All of the resistors have been removed from the bias pot, and the center wire, wire has been rehomed here to the center. This section is now an AA864 standard. This section, same thing here, and this section is Tweed. All the electrolytics have been replaced. Everything has been cleaned. And I also found in that kit that Mike sent from VintageFenderAmpRepair.com, he actually did include 2 1% 1 ohm resistors. So I ended up putting those puppies in there. And they work just as good as the quarters that I put in there, but now these are more robust, and those can probably just live in there. Not a big deal. This is just a balance pot, but it does bring that, you can home that bias in a little bit, as we've seen in an earlier shot. So let's see how it sounds. No feedback. Hear the difference there? So here's the feedback. No feedback. Feedback. No feedback. I'll get a little boost in dB as well. It's just the overall liveliness of the amp comes alive. So this is premium sound for me right here. Thank you, VintageFenderAmpRepair.com. I got a great amp now. Appreciate it.